Hi everyone, in this video we are going to discuss the mole. So the mole is simply a word that has a specific number attached to it. So the best way to talk about the mole is to do an example. So let's look at carbon 12. So we know carbon 12 has 6 protons and 6 neutrons. We know that in 12 grams, that's its atomic mass, we have 6.02 times 10 to the 23rd atoms, carbon atoms specifically. And so what we want to do is use the word mole instead of saying 6.02 times 10 to the 23rd atoms. So the word mole, which we actually write as MOL when we're doing it as a unit, we drop the E, is simply an Avogadro's number of objects. So if we say that we have 6.02 times 10 to the 23rd atoms, that's an object, right? That is 1 mole of carbon. So let's kind of go through this and explain it in a deeper meaning. So when I say 1 dozen, you immediately think 12. So if I say we have a dozen donuts, you're like, we have 12 donuts. If I say we have a baker's dozen, you would be like, oh, that's good. We have 13 donuts. We could talk about a decade. I'd say if a decade has passed, you would say that would be 10 years. If I say it's a century has passed, or my dad does century bike rides all the time, so that would be 100 miles on a bike. And then we could say a marathon. We have crazy people out there who run marathons. I don't know how you do that, people. Props to you. That's 26.2 miles. Or we could say we have a mole. And now I hope when you hear the word mole, you go, oh, that would be 6.02 times 10 to the 23rd things, objects, whatever it is we're talking about. So let's get a grasp on how big that number actually is. So let's say we have 1 mole of donuts. Okay, so that means I have 6.02 times 10 to the 23rd donuts. Okay, now we have 7 billion people on this planet, so 7 billion people. If I decided I wanted to give out all these donuts equally to all of these people, that means every single person is going to get 86 trillion donuts. Every human would get 86 trillion donuts. So please, 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 when we talk about a mole, I don't want you thinking, oh, it's 1 mile, it's 2 miles, or whatever. It would be 6.02 times 10 to the 23rd miles, or whatever unit or object we're talking about. It is a gigantic number. So now, we are talking about this because we often use the term molar mass. And that is simply the mass of 6.02 times 10 to the 23rd atoms. But we refer to this as 1 mole. So the best, 1 mole. So the best definition of a molar mass is simply the mass of 1 mole of each either element or molecule. We can apply this to molecules now. So let's go through some of these. Let's talk about carbon. Carbon, we say, has a molar mass of 12.01 grams per mole. We could do it with my favorite element, palladium. Palladium has a molar mass of 106.4 grams per mole, or 106.4 grams per every 6.02 times 10 to the 23rd atoms. We could also do this for molecules, so let's talk about diatomic nitrogen. So what you do here, since there's 2 nitrogens, you have to add that nitrogen value twice. So the atomic mass of nitrogen is 14.01 grams per mole. You would add that to another one, because there's 2 of them, 14.01 grams per mole, and you would end up with 28.02 grams per mole for the molar mass of nitrogen, the molecule nitrogen. And let's say we could do this for H2O. So H2O has 2 hydrogens. Hydrogen has an atomic mass of 1.01. We could add that to our oxygen, which has an atomic mass of essentially 16.00 grams. And we add that together, and we end up with 18.02 grams per mole. Now you do one. What is the molar mass of carbon dioxide? Go. Did you get an answer? Hopefully you did. And so all you had to do was add up the atomic mass of every single component in this molecule. So we have 1 carbon atom, so that has an atomic mass of 12.01. Then we can add that to 2 oxygen. So 2, and then the atomic mass of oxygen would be 16.00. We add this all up, and we get something like 44.0 grams per mole. I hope that makes sense. Good luck. Take care of yourself. Drink water.